Metallic bonding, bonding between metal atoms. Relatively simple in comparison to ionic and covalent bonding. Often comes up on exam papers, quite a regular question. The aim is the same with all bonding, it's to get a full outer shell of electrons. Now metal atoms, when they form ions in ionic bonding, lose their outer electrons. This is because they don't tend to have very many electrons in their outer shell. For example, magnesium, slightly better with a thinner pencil, magnesium has 12 electrons. So it has 2 in the first shell, it has 8 in the next shell, and it has 2 in the final shell. Those 2 in the final shell means that it's in group 2. Now, when you have a piece of magnesium metal, you only have magnesium atoms. They don't share electrons like they do in covalent bonding. What happens in metallic bonding is these outer electrons are lost. Unlike ionic bonding, they don't go anywhere because there are no non-metal atoms to accept these outer electrons. So these electrons just become lost between all of the metal atoms. When they do this, each atom then becomes an ion with a 2+ charge, and each one of these will have lost 2 electrons. Now these electrons don't have anywhere to go, they are delocalized, so they just move around the metallic structure. These are delocalized electrons. Now these electrons are responsible for some of the key properties that metals have. Most importantly, it's their ability to conduct electricity. Now, electricity is a flow of charge, and with a metal, the charge that can flow are these delocalized electrons. So the reason why metals can conduct electricity is because they have free electrons that can move through the structure. Now that's something that's quite important in answering the exam questions. They are free electrons, which all students seem to be able to get, and they're quite happy to write that down, but it's the idea that they move through the structure that's also important. That's the second mark. So to summarise the key points with metallic bonding, you have layers of positive metal ions. These are surrounded by free electrons. The electrons have come from the outer shell of the metal atom. There is a strong attraction between these negative electrons and the positive ions, which means that they have strong bonds and therefore they have high melting points. The electrons are free to move through the structure. So that's the important point here. You've got free electrons that move through the structure, and therefore they are able to conduct electricity. So those are the key things that you could be asked about. You could be asked about the structure of a metallic substance, in which case you talk about the layers, you talk about free electrons coming from the outer shell of the atoms, and you've got the layers of positive ions. You could be asked about the properties. They have strong melting points because of the attraction between the negative electrons and the positive metal ions being very strong. So they have high melting points, or you could be asked about their ability to conduct electricity. This is obviously linked between the free electrons and the fact that these free electrons can move through the structure. That concludes the metallic bonding video.